Welcome to all. This is part 4, part 1, part 2 and part 3. I considered all the principles and procedure also given. Everything is over now. Now part 4 and part 5 will be numericals. Part 4 is example 1. It will come singly in post. I have set the question. Next question, example 2 will be doubly in post. Then I will give 2 practice questions. Then I will wind up this one. Remember, before you start this, you have to first thoroughly go through part 1, 2 and 3 and also make fair copy, not simply reading it. Okay. Now, remember what you are doing, numerical examples for finding AST. When I give procedure, I never give only for singly doubly, common procedure. Numerical examples for finding AST required for Sri and AST and ASC for dry. Question I wrote here. See, read the question correctly. Then, rectangle section of RC beam 200 by 450. 200 by 450. Overall depth is subjected to factored BM of, I changed it actually, first I put 30, it's too small, I made it 60. 60 kN meter sagging. So sagging given, therefore top compression, bottom tension. So this is extreme compression. AST will be here. See, ASC we don't know whether singly or doubly. RCC means AST is always there. Okay, then decide, see what you have to do. It's a single sentence, taking M25 and FE415, comma, decide whether cross section is to be designed as, don't write this way, write full, singly reinforced or doubly reinforced, and accordingly find cross-sectional area of longitudinal reinforcement required. Take effective cover of 50 mm to tension steel. Here, tension steel 50 mm. And if applicable, means what? Suppose the cross-section comes singly reinforced, that's all. By chance, if it comes doubly reinforced, take effective cover of 45 mm to compression steel, given in the question. If it comes singly, this is not required. Okay. Now, B, 200. I told last time data. I wrote everything. Effective depth D, 450 minus 50, 400. M25, FCK, torque steel, FE415, X max by D, IS code 0.48. Bending moment to be resisted by cross section M. See, make a note, this is not MU. Whenever they give bending moment, it is corresponding to working load. Unless it is specified, any section force given, bending moment, shear force or axial load, etc., it is always for working load. So, 60 kN meter, they told sagging, okay, sagging is not required, already over, 60 kN meter sagging. Okay, now, understood, corresponding to service load or working load. Therefore, very, very important. If you forget this step, it is a criminal mistake in the design field. You are designing a structure to reach limit state or collapse state at working load only. So, taking gamma F equal to 1.5 as per IS code, factored BM MU 60 into 1.5, 90 kilonewton meter. This is basic data we wrote. Now, this I will remove and continue further I will continue. Okay. Up to here over, I even added something else. I even wrote what is required. See, required to decide whether our cross section is to be designed as singly, don't write SRI, singly reinforced or doubly reinforced, and then if singly reinforced, we have to find AST required, and if doubly reinforced, we have to find AST required and also AS required. In that case, you have to take D dash equal to 45. Nobody will write this much details. Why I am writing again and again, so that doubts are not there. Okay, now start. I already given procedure for you. See the procedure? I told first find MU limit. This statement I told so many times, MU limit. Write the formula for MU limit. Substitute 0.36 x max by d, 1 minus 0.42 x max by d is there, into 200, 400 square, 25, it will come 110.37, red color. Then I told, compare mu with the mu limit. Mu 90, 10 to the power 6 not required. Limit 110.37. So your mu is less than mu limit. Cross section is to be designed as singly reinforced, for which we have to find only AST required. Now, we have for a singly reinforced section, you can add one extra class. It is either under reinforced or balanced. When mu is less than mu limit, it is under reinforced. By coincidence, if it is equal, still no problem, balanced. You can write mu equation in terms of tension. You know this equation. I told already. This is equation for expression for mu in terms of AST. Okay, substitute. Mu 90 10 to the power 6, 0.87 Fy, AST, D, etc. Right. Note, this is quadratic equation. Why? AST into AST. Solving, how to solve quadratic, that I will not tell. If you cannot simplify this one and solve the equation, quadratic equation, better not continue any of my classes. Okay. One, you will get AST. One of the value is 735.40 positive, other is 4083.88. Now I told you, two values are there. Which one to consider? I'll do one thing now. I'll write here because this I don't want to remove. Because reason is there. Next question I am giving factor bending moment. So this space is not required. So I'll continue now. Last statement over. Last statement. From here, continue. I told taking least value. I told already least. Why least? I may explain if I take the star cast. Least value, right? Value for given cross section. AST required equal to 735.40 mm square. Over, right? Solution over. Because we are asked to find only requirement. Providing comes number of bars, minimum steel, that all comes in the design. Structural part, that is strength point of view, this is the required area of tension steel. That's all. Question 1 completely over. Now you will go for question number 2. Same way, question number, not now, because I will give in part by part. So this part 4 is question 1 over. Next part, I will give question number 2. Okay. Thank you. Anything pending? Nothing pending. Okay. Thank you.